All right, welcome to the Explainer. Today, we're doing something, well, pretty incredible. We're going to build a machine that understands language, and we're going to do it from the ground up, piece by piece.
I mean, it seems like pure magic, right? How does your phone actually get what you're asking? Well, it's not magic. It's a science called natural language processing. You'll hear it called NLP. And really, it's all about teaching machines our most human skill, language.
Okay, so here's the game plan. We're going to cover how machines read, how they break down text, understand grammar, and then, get the real meaning. We'll look at the tools they use and finish with a big challenge. Think of it like climbing a pyramid of understanding, one layer at a time.
So, first things first, how do machines even begin to read? A computer can't just glance at a sentence and get it. Nope, it has to analyze it through a whole series of phases, and they get more and more complex as we go.
And here's that roadmap. We start at the bottom with lexical analysis, basically just asking what are the words. Then we move up to syntax, semantics, all the way to the top, pragmatic analysis. That's where we ask, what did you really mean? We're building from scratch all the way to understanding nuance, just like a person.
All right, let's lay the foundation. The very first step, our first layer of the pyramid, is all about breaking down raw text into manageable little building blocks.
This first step is called lexical analysis. So if you take a simple sentence, the cat sat on the mat, this process just chops it up. It creates a list of what we call tokens. The cat sat on the mat, and even the period. It sounds super basic, right? But it's an absolutely crucial first step.
Okay, so now we have our words, our tokens, but we need to standardize them. I mean, think about it. The words running, runs, and ran all point back to the same core idea, right? The verb run. A computer needs to figure that out too, and there are two main ways to do this: stemming and lemmatisation. And trust me, there's a big difference in how smart they are about it.
And this table really nails the difference. Look at that example. Stemming, well, it's kind of fast and crude. It just hacks off the end of the word studies and gives you studi, which, isn't a real word. Lemmatisation is the smart one. It actually uses a dictionary. It understands the language, and it knows the proper root word, or lemma, is the actual word study. Way more accurate.
Okay, so we've got our clean, standardized words. Now what? Well, the next step is to figure out how they fit together. We need to understand the grammar. This is where the machine learns the rules of sentence structure, a process we call parsing.
You can think of this as diagramming a sentence. You remember doing that in school? The computer looks at the cat sat and checks if it follows the rules. It says, okay, the cat looks like a noun phrase and sat looks like a verb phrase. Yep, this structure is grammatically correct.
And one way it can do this is with something called top-down parsing. I love this analogy. It's like a detective who starts with a theory. The theory is this group of words is a valid sentence, and then it works backward, looking for the grammatical evidence to prove its case. And here's a perfect example of that in action with the dogs cried. The parser starts with the big goal, find a sentence, S. It knows a sentence can be a noun phrase followed by a verb phrase, so it checks. The dogs, yep, that's a noun phrase, success. Then it checks, cried, yep, that's a verb phrase, success. So the whole thing checks out. It's a valid sentence, mission accomplished. So the grammar checks out, the sentence is valid, but what does it mean? Now we're climbing higher up our pyramid, and this is where things get really interesting. This level is called semantic analysis, and the key here is we're moving from just structure to actual meaning. The cat sat on the mat is no longer just a collection of nouns and verbs. The machine now understands there's an agent, the cat, performing an action, sitting, on a location, the mat. It gets who did what to whom. But of course, we rarely speak in single, isolated sentences. And this is where discourse analysis comes in. It connects the dots. If you have, the cat was tired, it went to sleep. Discourse analysis is what figures out that it, in the second sentence, is talking about the cat from the first one. It understands the context. Okay, but what about what we really mean? The stuff we don't say out loud, the intent behind the words. This brings us to the very top of the pyramid, the most human-like level of all.
This is pragmatic analysis, and it's all about intent. When someone asks, can you open the window? They're not asking about your physical abilities, right? It's a request. Pragmatic analysis gets that. It understands what's meant, not just what's said. And that's the peak of our pyramid, moving from literal text to real human intention.
Okay, so that's the theory. That's our whole pyramid of understanding. But how does this actually get built? How do developers take these ideas and turn them into real-world applications?
Well, the good news is they don't start from scratch every time. They use these incredible libraries, which are kind of like super advanced toolkits for programmers. You've got things like NLTK and SPACY for the fundamentals, and then the heavy hitters from Hugging Face that give you access to state-of-the-art models like BERT and GPT. These are the engines behind so many of the AI tools you use every day.
So modern NLP it's just unbelievably powerful. But all of that power comes with a really big and growing challenge. And that is the problem of the black box.
See, a lot of the most advanced models, the ones that get those mind-blowing results, are essentially black boxes. They spit out an answer, but we can't actually see how they got there. We don't understand their reasoning. And as you can imagine, that can lead to some pretty serious problems.
And this is why it's such a huge deal. First off, debugging. If the model makes a mistake, how do you fix it if you don't know why it made it? Then there's bias. These models learn from massive amounts of text from the internet, and they can easily pick up and amplify harmful human biases. And then there's trust and accountability. I mean, how can a doctor or a judge trust an AI's recommendation if it comes with zero explanation? And finally, there are even legal issues. Some laws are starting to require a right to explanation for automated decisions. The stakes are really, really high.
Which leaves us with what might be the single most important question for the future of all this technology. It's not just about building machines that can understand our language anymore. It's about whether we can ever truly understand them.